Hi everyone, welcome you to your today's session with Harita Hive. Just give me a moment. Yes. So today we will be learning what is the today we'll be learning about the spatial indices in remote sensing. I'm your instructor for today's session. My name is Akshay, and welcome to the session again. So, we will understand what spatial indices are, how to actually use them in remote sensing, and to perform spatial indices, first we need to download the satellite imagery from the Landsat 8 or the Sentinel 2. That is the most popular freely available data to us. So we'll try to download the data from there. I'll explain how we can download a data for our area of interest. And for that, and after that, uh, just a moment. Yes, and after that, we'll proceed. Okay. So the first thing is, what are spatial indices? Spatial indices are numerical indicators derived from satellite or spatial data. They combine spectral bands to highlight specific surface characteristics widely used in remote sensing, GIS, and environmental modeling. Why are they important? They enable efficient analysis of large scale geographic data, support decision making in agriculture, forestry, and urban planning, help monitor environmental changes over time, provide quantitative measures for comparison and modeling. Now, there are some common spatial indices, that is, for example, NDVI, EVI, NDWI, NDBI, normalized difference vegetation index, normalized difference water index, normalized different built up index. So, in today's class, we will derive some of them. We will calculate NDVI using the satellite imagery of Landsat 8 as well as Sentinel 2. We will try to also calculate the NDWI, that is the normalized difference water index, and then we will try to do some further analysis with it. So the first thing, we are going to now download the data from the Landsat 8 imagery. So to download a Landsat data, you need to go to Google and you need to look for USGS Earth Explorer. So once you look up for this, you'll find the link for USGS Earth Explorer. Click on it. In general, when you visit it for the first time, it will ask you for a login. And it is important that you log in, because without logging in, you cannot create your download the data. To create a login, if you don't have an account with USGS, you can click on this create new account here, and you can create a credential ID with the USGS. So for example, I'm going to log in with my data. Now, once you log in this website, the interface looks like this. If you see on the left, there is something called as US feature or world feature. If you are looking for an area that is outside of the US, you can select the world feature. If you are looking for some area that you are working with, it is in the US, you can select the US features. So, for example, we are going to search for some city in India. I will click on world feature, and in the feature name, I will look for this city's name, that is Chandigarh. So once I click Chandigarh, once I enter Chandigarh and I click show, you can see the result is being loading. Now it gives me one of the places that it could find. If I click on Chandigarh, it will put a place mark on that place. Some of the locations might not be available in their database, but if it is a proper destination, proper city name, you can find it there. Okay. So as you see, the Chandigarh is available here. Now there is this option that uh, something called here as use map. Now you can just cross on this place mark because you already know your location, right? So if you want to download the data for some certain area, for example, if I want to download the data for this area, now I can add some coordinates here. Simply click on this and add some coordinates, or I can just simply click on use map and it will give me 4 place marks when I zoom out, and I can move those place marks according to the area of interest I need. So for example, I want to find the data for this place. So I've created a bounding box for the area of interest, right? If you want to delete it, you can simply click on the cross and it will go away, or click on clear coordinates and then again you can draw a bounding box. If you have your own KML or SHP, you can add it here, right? So if you see on the left side, there is this data range option here. So this is for the purpose to select a range of the dates from the time for which you want the data. For example, if I want to look up for the data from last 1 year, okay, or maybe last 2 years, so you need to fill up the data from when to when. Let us choose maybe 1st January 2025 up to today's date, that is 22nd January 2026, right? Now there is another option here that says cloud cover. If I click on cloud cover, you will see that there is a range bar which I can change. Now I am for sure that images with high cloud cover are not much useful. So what we can do is we can change the cloud cover range and we can maybe move up to 30%. We can look for a we can look for a range that is more suitable and we can work upon. If your image has, for example, 70% cloud cover, it may not be useful to you. And also you have to check if that cloud cover is in particular area of your interest, then it is not useful. Okay. So it is always better to check the cloud cover range. So the next thing is I will click on this dataset option here. It will show me the various datasets available in USGS. So these are many different kinds of data available with USGS. But currently we are going to work with the Landsat. So once you click on Landsat, you can find the Landsat collection 2 level 2 here. Okay. Just simply click on it and you will find the Landsat 4, 5, Landsat 7 and Landsat 8, 9 option here. So Landsat 7 and 4, 5 are the old satellites that had been working. Now if your data is from the past, for example, if you're working from some 1990s or 2000s, so you have to look that your data will be available in which Landsat series. It can be in Landsat 7, it can be in Landsat 4, 5. Okay, so accordingly you have to select the satellite. For now we are going to select the Landsat 8 and 9. Once you select it, so once you select this, just simply click on the results option. One more thing, we are selecting the Landsat collection 2 level 2. Now why we are selecting level 2 is there is level 1 product available, level 2 product available. The level 2 product is atmospherically corrected. It means because there are some distortions because of the atmosphere which needs to be rectified, and it has been rectified in this level 2 product. So we are going to directly download the level 2 product. Sometimes the level 2 product is not available to us. Then if you are downloading a level 1 product, you, before doing any kind of analysis, you have to do the atmospheric correction by yourself. Okay. Now just simply click on results. So if you see, the data appears here from the latest being at the top. So sorry, yeah, the latest being at the top. Now the latest data available to us is from 12th, that is December 2025. Now there is this footprint symbol here. If you click on it, it will show how the satellite has taken an imagery. It will show a footprint of that. So for example, this was my area of interest, and this satellite imagery is about this area. If I want to have a preview of it, I can just simply click on this preview button. It takes a little time to load, but it gives me the preview of the imagery. So you can see here there are a lot of clouds in this imagery, so I will not be it would not be wise to use this one, right? So let us check on some other imagery. So this one looks fine. And this one also looks fine. So to download the data, there, if you see, there is this symbol here, download option. If you click on it, you will find some options here. If you want to select some data, like if you don't want to download all the files, you can click on this select files and you will get the option to choose the bands. Otherwise, what you can do is, if you click on the product option, then also you will find the bands here. You can directly add the bands to the cart, and you can add all to bulk and download it. Or if you want to download the complete data, that is all of these bands, if you want to download the complete data, you can just simply click on this one. Okay, so I hope the part of downloading the data from the Landsat is clear. Once you download the data will be in the tar file. So this is the file. You have to extract it, and once you extract it, it will show you all the bands here. So the folder contains all the bands. Okay. Now I will show you how to download the data from the Sentinel-2. What you have to do is just simply go to Google and write download Sentinel-2 data. So once you write it, you will see that the Copernicus Data Space Ecosystem website appears. Click on that website. There is an option here highlighted in white that says explore data. Click on this option. And in this option, after clicking on that option, the main website will open, and it says to continue browsing, please log in or continue anonymously. But to download data, you have to again log in. So you can create a login for the Copernicus website. So once you create login, there is on the left the option to add your username and password. On the right, if you don't have an account, you can just simply click here on register and create an account. So once you log in, the interface looks something like this. Just like the USGS Explorer, you will find the option of going to the place here. In the USGS Explorer, we had the option here, right? The US feature or the simple feature. Here on the right top, you can find the place option. For example, if I enter Chandigarh here, so if I click, So this is my location. Now if you click on this search button here, if you have a time range, if you want to download data for certain time range, okay, or if you know your selected date, if you know one particular date for which you have to download your data, you can simply collect on this date single. But if you want to give a range of data, like if I'm looking for a data from the this 1st of January 2025 till today, then you just click on this search button here. First click on search and then you will find Sentinel-2 here. Recently Sentinel-3 has also been launched, and the product for Sentinel-3 are also available on this website. So simply click on Sentinel-2, click on L2A. Again, L2A means the level 2 product. L1C means the level 1 product. We are going to download the level 2 product because it is atmospherically corrected and we want to directly use it for analysis. So just click on this L2A product, choose a time range. So let me choose it from 1st of January. So once you select a time range, click on, just before clicking search, what you have to do is look for the area. For example, this is the area of interest. You will find this option here of creating a bounding box. So just click on it, and either you can draw a polygon or something like a irregular polygon, right? Or you can create this rectangular box. Just click on this and select your area. So once you select your area, just simply click on search. So the search will now be based on this area that you have selected. Just give it a minute, it will load. So if you see, I've got the tiles, the imagery tiles. So my data was like this, and the imagery that I have available is like either this shape or this shape, right? So I can look for the data. For example, if I just click on, if I see on the left side, if you see this first one, there is lots of cloud in it. So we don't want cloudy images. Just to check, for example, this one, you can see there is not much cloud here. Just simply click on this product info button and it will show you its location as well as how much the cloud cover is. Okay. So always try to look for the imagery which has less cloud cover. So let me try another one. Yes, this looks fine. So if you don't want to download all the bands of this imagery, if you don't want to uh, check out all the bands, if you want some particular bands, what you can do is go to this download single file option, and in granule, in the folder granule, then again in this folder you will find another folder called as image data. Simply click on this image data. You will have 3 folders. So these 3 folders are different resolutions bands. So for example, the bands with the resolution of 10 meter are included in this folder, and the bands with the resolution of 20 meter are included in this folder, and simply the bands with 60 meter resolution are included in this folder. So for example, if I want to download a certain band from this 10 meter resolution, I'll just simply click it and I have the option to directly download it. Once I click it, it will start downloading. Okay. The other option is if you want to download all the data together. That is, you simply click on this download button here. Now, once you click this download, it will not directly download you to your browser. It will first download in this bar here. So if you see 1%, once it reaches 100% here, then the file will be available to you and it will directly download itself. Okay. So for Sentinel-2, first it does a on browser downloading and then it is available to you. Now, the Sentinel-2 data, when you download, it is also in a zip file. Okay. So I have extracted this file also. So as it shows, it has subfolders inside of it. Unlike Landsat, in Landsat all the data was available in just a single place, whereas in the Sentinel-2, the data is available in the granule folder and further in the image data and then based on the resolutions. Okay. Just a moment, let me check if anyone has put some doubts or okay. So some students are asking what is the name of the topic. The topic's name is to understand spatial indices, how to download and how to create NDVI, that is normalized difference vegetation index, also how to create NDWI, and initially I've started with how to actually download the satellite data from Sentinel-2 and Landsat 8. Okay. Now, once the data is downloaded, to perform this spatial indices, you can download the QGIS software. Just go to Google and look for QGIS. So once you put in QGIS, there is this website that is qgis.org. Simply click on this qgis.org. You will find the download option up here, right? Just simply click on this download. Here you will find this option that is skip it and go to download. If you are generous enough, you can donate. Just click on this skip it and go to download. And there are two ways to install it. It is best to install it with a OSGeo 4W installer. So just click on it and download the installer, and then you can further install it. If you are using something else other than a Windows, you have the options here. Just select that option and the file according to that will showcase here. Okay. Now, QGIS is an open source software. The other software available to us is the ArcGIS Pro, which is a proprietary software. If you have the access to that software, then also you can create NDVI and these spatial indices in that. Okay. Now, before going ahead to actually calculate that indices, first I want to make sure that we have a look at the bands of Sentinel-2 and Landsat 4. Okay, so just a moment. Now, the Landsat 8 as well as 9, if you see here, it has 11 bands. The wavelength is mentioned here. The resolution is mentioned here. More or less, the resolution of all of them is near 30 meters. The unique panchromatic band has the resolution of 15 meters, and band 10 and band 11, they have the resolution of 100 meters. Now, Uh, if you see, the most widely used bands are for true color images that we use is band 2, band 3, and band 4. And then we have available band 5, that is the near infrared region. Then we have short wave infrared, then another part of that short wave infrared, then panchromatic cirrus, right? So these are 11 bands in the Landsat 8 and 9. For Sentinel 2, we have around 12 bands. This is the mentioned wavelength. Now, for Sentinel 2, one advantage over the Landsat 8 is the resolution. The resolution of many of the bands available in the Sentinel 2 is 10 meters. So if you look here, there are many bands that have the resolution of 10 meters. Then there are many bands with the resolution of 20 meters. Okay. So overall you can say that the resolution is much more higher as compared to Landsat 8. So if you have, because both of them are freely available, so if you are having Sentinels 2 data, I would suggest to use it. It would be much more, the analysis will be much more detailed. Okay. Now, first we will try to understand about NDVI. Okay. Now, there is an index. What actually the index is, because I just showed you these bands, right? The bands that I just showed you. When you use these bands in combinations to each other in an empirical formula, we are able to understand the objects on the ground better. Okay. There is a theory behind it based on their wavelengths. If we use these band ratios, we are able to get better understanding of our surface, of the objects on the earth, whether it is vegetation, whether it is any other object. Okay. Now, one of the formula being of NDVI, it is called as normalized difference vegetation index. Okay. This is the formula here, NDVI, that is near infrared band minus red, near infrared band plus red band. So let me just take you back to Landsat 8. So band 5 was near infrared and band 4 was red band. So what it actually means is, I want to, if you see, there are two components to it. The upper component says near infrared minus the red band, and the lower component says near infrared plus the red band. So we will be adding pixel by pixel. We are able to do these operations in the softwares like QGIS and ArcGIS. What we are going to do is, we are going to use this formula, and using these two bands we will generate one product. So just go to your QGIS. Let me open my QGIS. Now, why this NDVI is important? So this is just one indice, but what is the importance of it? For example, if you are one working in an agriculture field, okay, so NDVI helps us understand the healthy crop versus the non-healthy crop. Based on this ratio, we get a value. Now, the bands value of these, if I'll show you in the practical, it will I will show you this part of the expression in the practical that will help you understand more. Just wait a moment. So you saw that I already downloaded the Landsat 8 imagery, right, as well as the Sentinel 2 imagery. Now let me just go to this option here that is in QGIS called as layer. In this layer, I have this option called as add layer. In this add layer, I have this further option called as add raster layer. Once I click on it, you can see it shows it gives me the option to locate the source. So I will just simply click on this browse. I will go to my computer where I have extracted that Landsat file. So I just click on it. So because if you remember from the formula, NDVI works on near infrared and red, and in Landsat red is band 4 and near infrared is band 5. So for now I will just select these two bands, that is band 4 and band 5. So I will look for band 4. This is at the end of the name of this file, it is stated which band it is. So this is band 4 and this is band 5. I will just click on my control button and select both the files after, and simply click on open. Okay, so both my files have been loaded here. I will simply click on add. So the both files are here now. If you see, if I just visualize band 4, this is band 4, and if you want to visualize band 5, this is band 5. So if you had the theoretical classes with us, you can understand how the difference, why is there this difference on the ground, how the grayscale is different, what does these values means, right? So now when I will be creating a single product out of them, when I will be using this NDVI, there will come out a value which will range only from -1 to 1. Okay, unlike the original values. The original values if you can see, is 7,000 something, 12,000 something here, 9,000 for band 5. So these are the digital numbers here, but we are going to use an indice and bring it to the range of -1 to 1. So what I'm going to simply do is, if you look on the top, there is this option called as raster. Simply click on raster and you will find raster calculator here. Okay, so once you click raster calculator, both the raster layers will be already available here. Now for the to express it simply, if you see there is this raster calculator expression. This is where you have to put in the formula. So if you recall the formula of NDVI, it is NIR minus red by NIR plus red, right? Now okay, just let me check if there are any comments. So I just wrote down the formula here, right? So if you see from the PPT, in Landsat 8, NIR was band 5 and red is band 4. So for NIR, just let me select this NIR, and instead of it, double click on this band 5 and this band 5 will get inserted. And again select this red part and click on this band 4, double click on this, and this band 4 will get inserted. Similarly, do it for the denominator part of it. Okay, so band 5 plus band 4. Now we need to save the file. There are options of selecting what our data output can be, but it is generally preferable that because it is a raster format, we should select GeoTIFF. Okay. Now, so this is the NDVI that I'm creating using the Landsat. So I will call it as NDVI underscore Landsat. So I will simply click on OK. A new image has been generated out of these two. So in general terms, I say that a new product I created using empirical formula out of these two bands. So what does this new product showcase to me? Now, if you go back to your PPT, the value is ranging from -1 to 1. So the value is between -1 to 1. So if you see, it is 0.1391 to 0.498. Okay. So it is ranging between -1 to 1. Now, for NDVI, we can say that if the value is between zero point 0.6 to 1, it is a very healthy plant. If it is from 0.33 to 0.66, it is a moderately healthy plant. If it is 0 to 0.33, it is an unhealthy plant. If the value is from -1 to 0, either it is a dead plant or it can be anything else. To be on a safe side, it is generally said plant will always have positive values between 0.2 and 1. So there is a threshold defined that anything that is 0.2 and above, it has a probability that it is a plant. But below 0.2, you can be definite that it is not a plant. Okay. So negative values correspond to areas with water surfaces, man-made structures, right? It can be rocks, clouds, snow. So if I go back to our NDVI that we generated and I right click on it and go to the properties, we have the option of symbology here. I will click on this symbology and click on the single band pseudo color. Okay. Now in this pseudo color, I have the option to give it a color ramp. So maybe I will just choose this spectral color ramp and click on apply. Now what it does is it breaks the values into some different classes. The classes are defined here. It is broken into 5 classes. If you want to make classes by yourself, you can just simply click on equal intervals and change the number of classes, right? Now if I click apply, you can see here I am able to visualize it better. So if you see here, this is a river. You can identify by the shape of it. This is a river and it appears red to us. Now why is this appearing red to us? Because if I use this identity tool and I click on it to check the value of the pixel, it is -0.11. So anything that was below 0.2, it is not a plant. So all the objects in this image, if I click anywhere, so if I clicked somewhere here, it was 0.3. So it has a probability that it is a plant. So more the green it is, if you see in this color index, more the greener it is highly likely to be a healthy plant. It also depends on which season your imagery has been taken. The values for autumn will be different. The values for spring will be different. The values near December, fall, it will all be different. Okay. So based on the season also, your NDVI varies greatly. Okay. Now, okay. Yes, this will also remain in the recorded video channel. Yes. So this is the overall NDVI image that we generated from these two bands. Okay. Now the motive of this practical is, you are an GIS analyst. Okay. For you, it is now simple that you understand whenever you click on a pixel, you get a value 0.2, and you can simply check that 0.2 means maybe a unhealthy plant. Okay. Now, because of the season, whichever season this image was taken in, we don't have any healthy plants here. You see that the maximum that we have is 0.4. So most of them are ranging in the moderately healthy plants. Okay. Now, if I want to present this data to some new person, some layman person who has no knowledge of GIS, how would I actually do it? So showing them this will actually be a little difficult, because if he's not a GIS analyst, he clicks here and he says the value is 0.17. What does it mean? What if I use a option which is available in both QGIS and ArcGIS, which is called as reclassify? Okay. So there is an option called as reclassify by table. I will just simply click it, select the imagery that I want to reclassify. Once I complete this operation, you will understand what reclassify means. So what if I give names to these classes? Let me call that -1 to 0 is 1. Okay. Let me say that any pixel value on our NDVI here, if I click anywhere, if the value, if it ranges from -1 to 0, let me reclassify it as 1. Okay. And any value that is from 0 to 0.33, let me reclassify it as 2. And then just a moment. So let me say the value of this is 1. Let me say the value of this is 2, and let me say the value of this is 3. So in our imagery, we don't have any pixel values that range from 0.66 to 1. So we are not going to classify it. Okay, we are just leaving it like this. So I'm going to classify my data into 3 new classes, that is 1, 2 and 3. This, why I'm doing this? So that if I'm showing my data to some layman or some other business entity, to my boss or to someone else, how can I present the data? Now, in this reclassify, there is this reclassification table option. Let me click on these 3 dots here, and you will find this empty space. Just click on add rows, because we want to classify it in 3 new classes. Add 3 rows. So we had -1 to 0. So minimum is -1 and maximum is 0. I want to reclassify it as 1. We have 0 to 0.33, 0 to 0.33. I want to reclassify it as 2, and 0.33 to 0.66. I want to reclassify it as 3. Now, any value that falls between -1 to 0 in that imagery now will be converted to 1. Any value that falls between 0 to 0.33 in that imagery will be converted to 2. Similarly, any value that is from 0.33 to 0.66 will be converted to 3. Now you will be a little confused, like these values appear twice. Why? Because if you go back to this parameters option, there is range boundaries option. So it is just including the maximum one. So I'm not choosing an option which will create a conflict, that is this one. In the minimum to the value, you see there is no equal to option. So in our table, this minimum value is not actually considered in this other class. So 0 will not be considered in class 2, it will be considered in class 1. Got it? So once I add all this reclassification criteria and I click run, I get this new imagery. So this imagery includes 3 classes now. Now in these 3 classes, wherever you click, you will get 2, or for example, if I click here, I get 1. Now you can simply just say, sir, 1 means dead plant or inanimate object. 2 means unhealthy plant. If I click on here, 3 means moderately healthy vegetation. Now in my area, I have an idea now, which is moderately healthy vegetation, which is not actually a plant. So I have kind of divided my image into 3 parts. Now what if I okay, that next thing that I want to explain is that we will do with NDWI. So this is the NDVI that we created with Landsat. Okay, now what if, okay, we can do one thing is go to properties for these reclassified raster, go to symbol, and in single band gray select single band pseudo color. So in this pseudo color, if you choose equal interval, just a moment, number of classes 3, so I'm giving 3 classes 1, 2 and 3 and I apply. So now I am able to visualize the data much better. So 3 shows the moderately healthy plants, 2 shows the uh, 2 shows the unhealthy plants. So for example, if you have a land here, okay, you can, or if someone asks you that can you check if my region is having a healthy plant vegetation or not, so you can use this NDVI, right? Now we will do the same with Sentinel-2's imagery. Let me remove all of them. Okay, so if we see in Sentinel-2, the red band is band 4 and the NIR band is band 8. So we need band 4 and band 8 to calculate the NDVI. Now I will simply, I told you one method that was to go to layer, add a raster layer and then locate the folder. Now the other method is you can just simply go to your folder. So Sentinel-2 data is located here. Go to the granule and in image data you will find this 10 meter option here. So in this 10 meter you will find band 4 and band 8. Just simply select it and drag it to your QGIS. So once you drag it to your QGIS, both the bands will appear. So if you see the difference between the band 4 and band 8, just making an overview analysis from this image. Like this is a village here, this is a village or city. Now I want to create NDVI of from these two products. Again I will go to raster calculator. My both products are available here, right? Now if you remember the formula, first the NIR, then minus red, then bracket close, divided by NIR plus red. I will save this as NDVI from Sentinel 2 and simply click on OK. So if you come up with any doubts, you can write in the comment section if you have any doubts. So again, if you see, the original values were something between 835, 6000 something, right? Now the NDVI that has been generated, it is between -1 to 1. Now we can again go to symbology and select the pseudo color, and in this pseudo color I can either add some classes, choose the other options like equal intervals, or simply click on OK. So now near the value of 1 is the, that is 0.7 shows the healthy crop vegetation. Anything above 0.66 was healthy crop vegetation. So if you see the darkest of green colors here, these are showing healthy vegetations. So if I click here, it says 0.60. So the more the color is green, the more it is a healthy vegetation. So 0.63, 0.65. Now again we are going to reclassify this image from the product. So I will click on this reclassify. This time we have values in all the range. So what we can do is, this time we will classify this as 4. This time we will take this range also. So go to the reclassification table, select NDVI, select the add rows here, add 4 rows here because we are going to reclassify it into 4 classes. So the first one was -1 to -1 to 0. Next one was 0 to 0.33. Then 0.33 to 0.66. And then 0.66 to 1. So simply click on run. If you want to save the file to your computer, there is this option here, reclassified raster. Click here and save it to your computer. Or if you want to create a temporary file, just click on a save to a temporary file. So I'm just now clicking run. Just a moment. Let me choose it again. Okay, so our tables just got Okay, so what I forgot was adding a value here. This is 1, this is 2. So if you see here, it classifies how the new classification is done. -1 to 0 is changed to 1. So this is the new classified image. It has 4 classes, 1, 2, 3, 4. Now you can change the symbology. Go to equal intervals, classes B4, and apply. So now all the 4 classes are available here. Now because this is a raster, right? What if I'm working as a uh, crop specialist and my boss tells me now, extract me all the values in vector form of all the healthy vegetation. He wants all the healthy plants out of this image. How to get all the healthy plants? Now what you can do is, there is a way to convert this vector, this raster to a vector. If you go to this option in raster, you will find conversion and raster to vector, that is polygonize. Simply click on it, select the reclassified layer, choose the name of the field to create as DN based on this 1, 2, 3, 4 values, that is DN. Simply click on run. It will take some time. So I have the vectorized output of it here. Now if you see in the attribute table, there is the classification here. Either it belongs to class 3, class 2, class 1. So as I told you, what if my boss is asking, show me all the very healthy plants in this region? What I can do is right click on it, click on the button called filter. Okay, select DN and click all. So the DN has values from so this is no data value, don't just ignore this, that is 1, 2, 3, 4. So I will click on DN equal to 4 and click on OK. So these are all the regions where I have very healthy plants. Okay, so this is actually how you use NDVI. Now let me do another showcase of using NDWI. What NDWI means, how can we actually work with it? So NDWI is used to we have a question, where can we download the raster? I joined late. Okay, hi Umran, I already explained that this data set can be, if you after this video session, you can just open this video again. It will be saved in the YouTube there. You can see from the very start, we have downloaded the data from the USGS Earth Explorer, that we downloaded the Landsat 8 from there, and then we used the Sentinel-2. We downloaded it from the Copernicus hub. Okay, now just to give you a basic idea, let me look for the definition for you. If you just simply go and look on Google what is NDWI index, it will tell you it is the normalized difference water index. It is a way that if you have some satellite imagery, you want to differentiate all the pixels that are associated with water bodies. So all the pixels that are associated to water bodies, you want to differentiate from every other pixel. So in NDVI, we differentiated vegetation from every other pixel. This index is used to differentiate water from every other pixel. Okay, so there are many indexes out there. So one of the example is NDWI, that is normalized difference water index. The value of it is this. Similarly, there are many other indexes also. So one other example is NDBI. If you want to extract the pixels related to all the built up houses, all the constructed buildings, that is called as normalized difference built up index, and the formula for it is here. Similarly, we have urban index. If you want to look out for forest fire or some kind of fire, there is this burn fire index. Soil indices to understand which is a dry soil, which is a uh, wet soil, different kind of soil types. Okay, then there is ice indexes. So for example, if there is a place where you have snow as well as clouds, you can use NDSI to differentiate snow from clouds. So we have this NDSI indices. If you want to have a complete detailed outlook about these indices, what you can do is you can simply go to this link, that is indexdatabase.de. So if you visit this website, you will find show indices for selected sensor. Okay, because the band number for each satellite is different, right? For example, in Sentinel, uh, the NIR is band 8, whereas in Landsat the NIR band is band 5. So because this serial number differs, the formula is also different then, right? Band 8 instead of band 5. So show indices for selected sensors, you have to just click here and look for which satellite you are working for. So for example, if I'm working on Landsat 8, so just select Landsat 8 and click on display indices. It will show you the many available indices, the many formulas that you can use for your analysis. Okay, so there are so many formulas. Just just click on it if you want to further know about that formula. Okay, just click on it and you will get the details of it. So now we are going to calculate the NDWI, that is normalized difference water index. So for normalized difference water index, simply just go to your QGIS. First, look at the formula of it, that is green minus NIR. Now, because I know that I'm working with Landsat 8, right? So green minus NIR, I have to first look what is the number of these bands. So in Landsat 8, green is 3. Sorry, green is 3 and NIR is band 5. So this time I'm going to use band 5 and band 3. So simply go to your QGIS, layer, add raster layer. So I will remove all the previous layers. So band 3 and band 5, I will add them and click on add. So I have both my band 3 and band 5 here. Okay. Now again we go to the raster calculator. This time the formula was green minus NIR. So green is band 3 minus band 5 closing brackets by band 3 plus band 5 closing bracket. So I will save this as NDWI derived from the Landsat and simply click on OK. So if you see, this is the new output generated. Again, most of the indices range from -1 to 1. Okay, so this time it is from -45 to 012. Let us visualize it. I will go to the properties, select single band pseudo color, click on apply. Just like NDVI, I have a different class here now. Just try to make an analysis by clicking on them. So if I click with my identity tool, if you can see, the range of water is 0.101. That is, it is above 0. Anything that is above 0 here, it shows as water. Okay. Otherwise, most of the values are in negative. So you can find the differentiation there, but we generally take 0 as a reference in this case. So everything else that I'm clicking on, it is coming out to be in negative. Whereas when I'm clicking out on water body, it is a positive value. So what I will do is, I will simply reclassify it into two parts. That is, I will add two rows. I will say anything from -1 to 0. I will say anything from -1 to 0 is 0, and everything from 0 to 1 can be 1. So simply click on run. So I've got a new classified layer. If you see, the water bodies are clearly demarcated here. Now I can change the symbology of it. I can go to properties, and in black to white, maybe I change it to white to black. So if you see now, I can see my water bodies very clearly. So this is how NDWI is used. I have differentiated it. So there are some more pixels. There may be some rainfall season. There is water collected here, or maybe this is farmlands which have small puddles of water there. Okay. Now, for example, if I'm working in a company and they tell me to extract all the rivers from the raster satellite. Okay. So I want to, this originally was this two raster bands. I created NDWI. Now I can extract this river from this also. So again, what I will do is, I will go to raster, click on conversion, and I will polygonize it. So once I polygonize it, you will see the data is very clearly demarcated, right? And if I turn off all the other layers and simply again select filter. Now, if you remember, I made 1 as the water body and 0 as non-water body. So I will click on DN, double click on DN, it will come here, DN equal to 1. And I will apply and click on OK. So I have all the water pixels here. So this is in vector form, right? You can delete all these middle things and you have this river body here. So similarly, you can do this with the Sentinel data. So this was all about today's session. If anyone has any doubts, please write in the comment box. I will answer them. Just let me know. Any doubts to anyone? Okay then. Thank you for joining the session, and we will meet in the next session. Okay.